Hello everyone. In our architecture series, I wanted to take a few moments and just talk about memory. Memory is one of the most difficult things to land properly when interacting with large language models. And there have been an endless amount of architectures talking about something called reference assisted generation, or RAG. And it seems that everyone has a different method of doing it. I wanted to share a couple of insights on how to make your AI significantly more beneficial by establishing your own deterministic and probabilistic, so logic-driven or AI-driven means of searching memory and then creating memory. And we're going to dive into a really high-level architecture. It's going to build on the concepts from the last video where we talked about tool usage, because memory in this instance is one more tool in the AI agent's tool belt for it to dive into. So let's have a look at it. As before, you have some solution user interacting, providing some sort of prompt. And in the interaction, before you really get into attempting to provide an answer, the question is, does the answer require memory? And in many instances, it's hard to say. So you can look at prompt triage there, and you can assume that maybe it's worth checking in any case. At the same time, besides creating the prompt triage, you can also create a memory at the same time. So every interaction is a means of laying down even more track, as it were, of memory. And so as you start to prompt, you also create a memory. And when you get into that, here's where we have a little bit of architecture that is worth unpacking. And this is as simple as I can make it. Of course, there's a tremendous amount more depth that you can create here. But as I've noted, preparing a memory enables its recall. And so just creating data or text or saving the prompt, that doesn't really cut it. We need something much more sophisticated. And so what we need is a tool here, which is a memory preparer. So preparing a memory means that you're enabling its recall. So just as humans have various types of memory, like semantic and episodic and sensory, the preparer is your toolkit, your toolbox on making those memories make sense. And so in here, I really have sort of two classes. One is tool-driven across the top, and the other one is AI-driven across the bottom. So let's have a look at the tools. So when you are processing an amount of data, one of the concepts that we have is to chunk the data up. That means to break it into its most smallest composite elements, and in case of a text, you might break that down into chapters, into pages, into paragraphs, into sentences, so you can use a logic-based structure there. And then depending on what you're working on, maybe it's a video, you're going to chunk it into frames, etc. The second is vectorization, so you're going to use a vector search algorithm to essentially transform that content in a way that enables its retrieval later. You can format and structure that content, so you can build a reliable structure. So you could take unstructured text and you could put it into a structured format. That would make it easy to search, for example, in a database. And then, of course, you can also extract keywords if it is a text-based interaction. And so that means you can use any variety of different libraries, like Spacey if you're using Python or anything equivalent. And you could parse out keywords based on a lookup catalog or even the regular expression. And so those are deterministic tools that are going to allow you to break your data down into smaller pieces. But you can also even use LLMs to help be your memory building agent. And so, for example, you could have an input where you are contextualizing the message. So what is the context of this message? Who is asking it? From what's the situation? So it's the content itself wrapped in a larger context, and that is really important, as we'll see in a moment. Summarization, so you can take a long amount of text and compress it down. Entity detection is a really good one, so the ability to understand the nouns effectively, the subjects, the nodes in a concept, and to start to break out the relationships between those. So you have Alice and Bob, and Alice works with Bob, and both of them work for the same corporation, and that corporation is incorporated in this jurisdiction, and those all become nodes, and the relationships are called edges. And then finally, there's categorization and taxonomy. So how would we categorize this information based on the LLM's knowledge? So how would it frame this information for future reference? And all of these are attempting to lead to storing the information in a way where we're preserving both context, but also content. And so content has no value without the context within which it is captured. And context has no value without some of the content that it has to make itself meaningful and descriptive. And so there's a continual narrative between context and content. And in there, you also would want to be capturing the data provenance, such as what is the source of this information, whether that be mechanical or contextual, so country or person or setting or scenario. Then there's the metadata. So for example, again, how long is it? What's its format, etc. And also the user context. And this is just as important as anything else, which is how is the person, what's the person's intent effectively in that space? And so if you can create a data model that has context and content together, suddenly you can use either door to discover the other. So for example, if you're trying to retrieve this information and you wanted to find a situation, well, you might find all of the images associated to a particular day or a trip. So the trip becomes the context. You could also use the content, right? So you could find all scenarios where you've gone on a hike. And that hike would guide you to all of these different contexts. And so there are two routes to come together. You can go through either door and find. And the best search algorithms, the best search methods will consider both and find you the best results, which are sort of the confluence of context and content. So say that 3 times fast. And then once you've got two things going on. Once you've prepared the memory and stored it, you also have this recollection agent. So presuming we agree that you need some memory is useful in this situation, you would have a recollection agent which would prepare a series of structured instructions to a memory API. The memory API has two critical components. One is a dictionary, so that is a catalog of all of the data types that it possesses, and one is a database, that's the actual content. So again, we have an important relationship between context and content, and the memory API would essentially hit both. First, it would say, what data sets do I have? And then once it found the best data set likely associated to what you're trying to achieve, then it would go to retrieving the data itself. And so the memory API would do that. And it's likely this two-step process. Then the last agent would be this memory retriever. Did any of the memories surface? Did the memories augment? And so it's kind of like tool usage where we're considering, does the tool help provide the answer? Let's go execute it. You would integrate all of those answers together, and then you would return the LLM's response back to the user. And so this is very similar to how you experience the world, whether you do this consciously or unconsciously, where you might walk into a building, and whether you've got memory or not will absolutely guide your pathway through the building. It'll absolutely guide the context in which you see that building, and it will influence your choices. And so the memory is always being augmented, like we have here with the memory preparer. The memory is always being retrieved, and the actual influence is being informed by the recollection of memory and the repetition and things like that. Now, if you thought probabilistic or non-logical language models that are unpredictable were challenging before, well, the memory integration actually makes it that much more challenging, because now every time you interact with it, if you've established the memory this way, it's remembering your last interaction, and so on and so forth. And so it's even more difficult sometimes to pin down reliable results once you integrate memory. But the quality of what you can achieve actually goes up significantly once you integrate memory. The last thing I'll note is that there's been some recent studies done and research done that also shows that too much information, too much context in a back and forth exchange actually starts to confuse large language models in the current architecture that they run in. And so you may choose to have memory optional, or you may choose to, in fact, limit the amount of memory. And we do that ourselves. We have short-term memory, which is informing what am I doing right now, what's the continuity of my purpose, etc. But that fades away and it goes into long-term memory, which maintains more of the narrative arc. What am I doing with my life? Where am I? Why am I here? Etc. And so you'll probably want to experiment with returning both or multiple types of memory, multiple structures of memory back to your language model when you are having these interactions. So I hope that's been helpful. I'm curious about how you're going to use memory. Within everything that we're building here in Alberta, memory is going to be absolutely key, whether it's reference information that's going to come from our systems of record, or whether it's context information that's going to come to help to inform defining really solid standards, or whether it is future goals and objectives, which are a different kind of memory, a kind of future memory, which is setting out where we want to go and maintaining the continuity of the thought throughout the interaction with the AI. So I would love to hear how you're incorporating memory into your systems, and we will be sharing even more examples of this as we embrace this agentic AI concept, and as we start to build more robust, consistent, and high quality outputs by building this concept of an AI factory where we have all of these inputs coming together, and we have essentially the nexus point between tools, between memory, between agents, all coming together into a single spot. That's where we're going to start to see the highest return on investment. So I'll be happy to share some of that information as we go forward. So thanks a lot. Have a great weekend, and keep on building.